5.2, we're talking about direct variation, which the equation, I'm not thrilled with it. It looks like it's different than what we're used to, but it's really not. So you've all probably heard this. The diagram shows the distance. You can figure out how far away a storm is from you by listening to the thunder. This says the diagram shows how long it takes to hear thunder after you see lightning, and what general rule can you use to make a model of this situation. So by the looks of it, it says, let's see, in 10, let's see, how long to see your thunder after you see lightning? 10 seconds, 2 miles, 15 seconds, it's 3 miles. So for every 1 mile, I can say what? So you should say for 1 mile, it would be 5 seconds. 5 seconds for 1 mile, 10 seconds for 2 miles, 15 seconds for 3 miles. Therefore, miles and time vary directly. That's what we're looking for here. Miles and time vary directly. For every 1 mile, it takes 5 seconds. What does that mean, vary directly? Direct variation are just equations that are in the form of y equals some constant k times x, where k is not 0. So if we look at this, so you should write that down, or you should highlight that formula, y equals kx. If we look at this, we would say ours would be y equals, we said 5x, so every 5 seconds it goes 1 mile is 5 seconds. So that would be our direct variation formula for thunder and storm distance. So if we look at this, how do we identify direct variation? Remember, it has to be in the form y equals kx. So first you have to solve for y, because you have to see what y equals. So in this case, we divide by 7, and I get y equals 2x over 7. Hey, is that y equals kx? Yes. Our constant, so this is a direct variation, with the k is just the 2 7s. Let's look at the next one. It says for solve for y. So to do that, I have to get rid of these x's, move these over to the other side. And when I do that, don't make monkey pines. I get 3y equals negative 4x plus 8. I can't combine the x's and the 4, or the 8, excuse me. And then I have to lastly divide by 3, because I have to get the y by itself. And I get y equals negative 4 thirds x plus 8 thirds. Is that in the form y equals kx? If you notice, this is just kx. There's no plus da da da. So I can't have anything in that spot. It just has to be kx. So this is not a direct variation. Because I have that 8 thirds coming along, and that 8 thirds can't be there. So I can't have kx. So let's look at this one again. We have to get y by itself. Here's where we had all that practice. I need to get rid of the x's, move them to the other side to begin with. And I get 5y equals negative 4x. I don't have to put plus 0 because that's negative 4x. And then I divide by 5. And I have y equals negative 4x over 5, or 4/5 x. Yes, it is a direct variation. There is no plus or minus something trailing at the end. This one, my x is already on the other side, but I have to get rid of the negative 3. Divide every single part by negative 3, and you get y equals negative 2x plus 3. Is that a direct variation? Not a direct variation. Because I have that plus 3. I can't have any number hanging out. It's just y equals something times x. No something times x plus something. Suppose y varies directly with x. Y is 35 when x is 5. What's the direct variation equation relating x and y? What's the value of y when x is k? So it gives me the direct variation equation. I know it's y equals kx, right? I have an x and a y, but I need a k. So how do I find that? I'm just going to take the y they give me and the x they give me. So y, 35, equals k times x. How do I get to find out what the k is? I get k by itself by dividing by 5. And I get k equals 7. So am I done? No, that's not my equation. So my general equation, like y equals mx plus b, where I plug in a m and a b, this one is just going to be y equals k, which is 7, x. So here is my direct variation equation. Then it says when x is 9, what's y? I'm just going to take my equation and I'm going to plug 9 in for x. So when x is y, 9 is 63. So that's the second part. So there's the two answers. You should put me on pause and try this and then come back and see what you get. There's the answers for the direct variation equation, which is right here. And part B, what's the value when x is negative 15, is right there. All right, writing a direct variation from a table. So if we have a direct variation, let's see. Well, let's see what happens here. So this goes up by 6, and this is going up by 4. This one goes up by 3, but this one is going up by 2. So if we're going to look at our rate of change, that would be 6 over 4, and this one is 3 over 2. Well, 6 over 4 can simplify. 6 over 4 equals 3 over 2. So it looks like my slope is consistent. But here's the deal. We want to know, does it vary directly? So we should be able to get a y equals k times x equation. So I can just plug in numbers. So if y is 6, and k, I'm looking for k. So I'm picking numbers from right here. I'm picking the 6 and the 4 out. So if I put the 6 and the 4 out, I get k equals 6 divided by 4, which equals 3/2. And I'm going to see if that's the same for everything. So let's try another set of numbers. If I plug in the two numbers 10 and do I get 15? So I am saying my k is this 3/2. So y equals k 3/2 times x. If my x is 10, do I get 15? And I do, y equals 15. So is it a direct variation equation? Yes. And if so, write an equation for it. Well, I would say y equals, that was ugly 3, equals 3/2 x. That is my direct variation equation. And now let's look at this next one. So this one, it looks like I go from -2 to 3 to 1, excuse me, is up 3. This one's also up 3. Actually, let's not even do that this time. Let's just try to figure out if we're talking y equals kx. Let's pick our first values and find a k for this. So y equals k times x. If I plug that 3.2 in, I'm looking for k, and I have the -2 for x. What do I have? Again, I have to get k by itself, so divided by 2. If I take 3.2 and divide it by -2, you get -1.6. So if this is a direct variation, my k should be -1.6. So let's take this, plug it into our generic equation. Y equals -1.6x will be my general equation. And let's try another set of numbers. So let's try this 4 and this 1.6. So if I plug in 4 for my x, I should get 1.6 if this is a direct variation. So I want to take 1.6 times 4, excuse me, -1.6 times 4. And if I take 4 times -1.6, I get -6.4. So I would have -6.4 as my answer. I should have gotten this 1.6. Since I didn't get 1.6, I know that this is not a direct variation because my y equals kx from my first set of numbers doesn't work on my last set of numbers. All right, that is it for direct variation.